Good time zone, Internet. Welcome back. So, as we have always done, well, as we have recently been doing, I return you to the equation sheet here, where you will see that I have included the two new equations from the previous episode. There is one thing that I want to point out before we move on, though. That being that a comment on a previous video had asked me to include my equation sheet, which I think is a good idea. However, I'm building up the equation sheet as we go, and having just seen that comment before making this video, I do not yet have a plan to execute on that, but I think it is a very good idea. I do want to acknowledge it, and I do want to follow through with it. I think, like I said, it's a good idea. So check the video description on this video and on future videos, because while I may not have a solution now, I may have one by the time that I post this. With the housekeeping out of the way now, I would like to turn our attention to the example that I have been building up to for the last two episodes. 3 weeks now, I think. 2 weeks. One of those. Anyway, this is the example that we have to work with. So our satellite, Sputnik here, very happy to be hanging around with us. Very happy that you're here, bud. So we have our happy little Sputnik. We have our orbit. This is the orbit that we have been working with the entire series up until this point. We're at a distance of 16,365 and change kilometers. We're moving at a speed of 5.36 kilometers per second. But Sputnik, they have decided that there's really not much more to learn from a closed loop system around the Earth like this. So with that in mind, they have accelerated through means scientific or magical, doesn't matter at this point, to a speed of 7.6601 kilometers per second at an angle of 48.0768 degrees. And, well, it wouldn't be an example without having a set of values to look for, right? So we are going to be looking for their hyperbolic excess speed, their outbound angle, and their turning angle. And because this is my series and this is a video dedicated to an example, they are going to be written in blue up here. All right, so let's start with perhaps the easiest one. I don't need to scroll down for this one. I don't need to scroll down. Let's start with hyperbolic excess speed, which I have conveniently written right here. Well, one of the equations for them. One thing I want to point out, my equation sheet here has V hype, so V hyperbola, but in the video I wrote it as V, just regular V. These are the same. This is just velocity of the hyperbola. This is how it was presented to me on my notes sheet. They're just the same thing. One of those things that I feel better for having explicitly said it, even though you could probably piece it together yourselves. Anyway, we have the equation for the excess speed here. So let's look into that. We have V hype squared is equal to Vs squared plus V infinity squared. I don't know how to pronounce that otherwise, so it's just infinity. So we know what this value is, and we can find this one pretty easily. So, well, let's solve for it. So we have V infinity is equal to the square root of V hyperbola squared minus V escape squared. And I'm going to break this down one step further just because I'm going to have to do this anyway. So v infinity is equal to square root of v hyperbola squared minus, and let's make sure we record this right. We have here our escape velocity, just the square root of mu over square root of 2 mu over r. Since this is squared, it is just going to be 2 mu over r. If I don't clear that one dot, it will bother me. And now we plug it in and solve. So I'm going to write that over here. We have v hype. This is our new speed, which is 7.6601 squared minus 2 times the gravitational parameter of Earth, 3.986 times 10 to the 5th. 10 to the 5th. Thank you very much, hand. And divided by our radius, which is 16,365.424. When you plug these into your calculator, you will get 3.15. I'm going to go ahead and write the whole thing. 668.7472 kilometers per second. And I'm going to box this in green because this is an example video and it's not going to be computing with anything. So go up here and I am just going to write in just the 2 decimals, 3.16 kilometers per second. All right. Painless. Easy. Makes you wonder why I had to make this its own video, right? Well, don't worry. We'll get there. So now we need our outbound angle, which is a cosine of -1 over the eccentricity, which I did not include here. We have the radius, the velocity, and the flight path angle. Okay. So all these equations that we've been working towards have been for the closed loop system. Okay. There's only one thing left to do. Panic, despair, retreat, concede. That is going to be it for the series because I don't think we have enough to be able to do it. Anyway, thanks for stopping by. Okay, I've had my fun. So, yes, we solved all of these equations for a closed loop 2-body situation, but it turns out that most of these equations are versatile enough that we can use them for a hyperbola, for a hyperbolic trajectory. I would not use that one because I think you're going to get some strange imaginary answers. We'll come back to that at a later time, I think. But for right now, let's hop back over to here. We'll scroll back down. All right. So we have an equation to get us the value that we want. We need eccentricity for it. And while we're here, let me go ahead and write down what we do know. We have a radius, we have a velocity, and we have a flight path angle. All right. Those things, radius, velocity, flight path angle. Oh, I got rid of those. I didn't mean to. Okay. Radius, velocity, and flight path angle. That, I have all three of those here, so I can get us I can get a nice angular momentum value. Let's see. Can I do anything with those four? Well, there's an angular momentum value here. Actually, I think it'd be easier if I did this. But I need to have... Yeah, that will get me an eccentricity value, but I need to have a semi-major axis value. Okay. I know what my V infinity is, so I know what my hyperbolic excess energy is. Energy is conserved, so I can use that in this equation. I can just equate them to one another. That will get me a semi-major axis. With an angular momentum and a semi-major axis, I can find my eccentricity. I can find the rest of them. Okay. All right, let's see if it works. Let me start with semi-major axis equation. So, scroll down to some blank space down here. I want the excess energy equation, which is the excess velocity squared by 2, and is equal to minus... don't lose track of your equations. Minus mu over 2a. Okay. That's looking pretty manageable. If I solve for a, then I can cross these two out. And I have that a is equal to minus mu over v infinity squared. With a positive mu value and a positive v, I will get a negative a, so that's nice. Let's plug in some values now. 3.986 times 10 to the 5th. I don't know why it's doing that. Over. Well, it's a good thing that I recorded every digit up here. Otherwise, I'd have to solve for it again. So, 3.156687472 squared. So you solve for that, and that will get you a number that is suspiciously close to minus 40,000. Boy, you would sure think that I did that intentionally, wouldn't you? There's no way I would do that twice. Twice in one series? No, certainly not. Certainly not. So we have an A value. We have a semi-major axis value. Now we need an H value, an angular momentum value. So with our V, not gamma, V, have it V2 cosine of gamma, we plug that in as 16,365.424 times 7.6601 times the cosine of 48.0768. I'll go ahead and include the degrees. Why not? For a value of 83,757.78785 kilometers squared. That is really a long tail on mine too. Hang on. Oh, God. Squared per second. Like all of my equipment has decided that it doesn't want to work with me right now. In fact, I'm tempted to check to make sure that the microphone is working. Give me just 1 second. All right. Now we have our A value and we have our H value. The last step on our grand master plan is to plug them into the parameter equation here and solve for eccentricity. For that, I'm going to give myself a little extra space. We have h squared by mu is equal to a times 1 minus e squared. Solving for e, 1 minus e squared is equal to h squared for mu times a. Squared squared mu by a, and then square root it. Mu by a. When you plug in the values, we'll have 1 minus 83,757.78785 squared over 3.986 times 10 to the 5th. The Earth is getting bigger. 10 to the 5th. Not 10 to the 10th, not 10 to the 15th. Goodness. Minus 40,000 kilometers. And plugging that in. So when you plug that in, give myself a little extra space, that's going to give you a value that is suspiciously close to 1.2. And it's at this point that I will admit to you that, yes, I did do it again. And you'll never stop me. All right, so we have an eccentricity value, which is what we've been searching for. So let's plug it in to our outbound angle equation, which is arc cosine of minus 1 over 1.2 to give us a value of 146.44 degrees. I'll box it here and I'll write it up in the upper right corner in just a little bit, because we also have our turning angle and we're right here. We may as well do this now. 2 times the arc sine of 1 over 1.2. That will give us a value of 112.89 degrees. All right, let's write those up here really quick. Oh, we did a lot of writing. We did a lot of writing, didn't we? All right, so we have 146.44 degrees and 112.89 degrees. And 23 minutes into recording, we've done it. We've solved it. So well, this is a perfectly reasonable time to end the video. I want to point something out that, you know, we had to go on this wild roundabout trying to get to the equations that we actually needed, but we could do it. And I want to remind everyone watching that the first 10 episodes were all solved from the initial conditions that I presented in episode 2. We didn't need anything else. We had a position and a velocity, not a speed, a velocity. That's very important. So with minimal input, we were able to solve for all of these equations. And similarly, here, we were given minimal input. We didn't really have a whole lot to start with. But in all that time, we found our hyperbolic excess speed, our semi-major axis, our angular momentum. We found our eccentricity. And if we wanted to, we could solve for everything else in this equation sheet, just about. So let this be a lesson that can be extrapolated from this material. Whenever you're given something that's a little confusing, a little mind-boggling, you don't feel like you have everything, get a little creative. Worst thing that's going to happen is you just spend a little extra time doing stuff that didn't work, but hey, maybe you find something cool along the way. And ultimately, doing something is better than doing nothing. And I think that is the point that I want to end on for this video. So thank you all so much for putting up with me for the last few episodes while I tried to figure this out. And thank you all so much for stopping by.